All right, welcome everybody to week 2, day 1. We got a very exciting class today. Some of the most important stuff in computer science will be covered today. So let's get to it. First of all, let's look at the quiz. 82% average score, not bad. Just reviewing what we talked about last class on Friday. So in plain English, what is this code doing? So remember, there's 3 parts to making a variable. There's the name of the variable. In this case, the name is number. The type, which is float, and the value it's initialized to, which is 3.5. And so the correct answer here is it is making a variable named number of type float with a value of 3.5. It is not making a variable of type number. That's not the type, that's the name. Okay. Yeah, and the other ones are even more wrong. I'm trying to read a value from the keyboard into a variable named x. What's wrong with this line of code? Seeing the arrows need to be going to the right. If you see out, if you character out, the arrows go to the left towards the see out. When you are dealing with a keyboard read, the values flow from the character input into x, so it should look like that instead. If you want to read from the keyboard, you need to use see out, not see in. See out is for the screen. The character output, see out, console output, sometimes people call it. Maybe inaccurately, who cares? See out is the screen. See in is the keyboard. And then you can use the modulus operator with floats. Nope. You will never have a remainder if you divide by 3.1. Because 3.1 will divide into something 2.9 times or something like that. There's never a remainder. It doesn't even make sense to have a modulus with floats. So that is the quiz. And there's my corgi background for today. So let's get to it. The first thing that we need to talk about is the assignment operator. So if we have x is equal to 10 and y is equal to 20, what I realized is we actually on Friday didn't talk about the assignment operator, which is actually really important. It's this operator right here, the single equal sign. And what that means is set the value of x to be 10. And here we're doing it as part of the initialization of the variable, but you can also do it whenever you want to change the value of a variable. So if you want to set the value of x to be equal to x plus y, what this says in plain English is x is equal to, set x equal to the value that x currently has plus y. So x is going to be set to the value of 10 plus 20. So x is now going to be 30 after this point. So if we were to see out the value of x at this point, then, not you, g++ main.cc, then it prints 30. Okay. And if we were to do x minus y, what value do you think we will get? What value does x become after this line runs? So x is equal to x minus y. What value do y'all think x is going to have when we see out the value of x? Let's see if your arithmetic skills are up to scratch. Yes, negative 10 is correct. Okay, and just verify that. There we go, negative 10. And if we do multiply, what value are we going to get? X, set x equal to the value of x currently times y. By the way, algebra people hate this notation because in algebra, equals means the two sides are equal, right? But in computer science, the equal sign, in C++ at least, the computer science means compute the value on the right-hand side and set the value of the left-hand side to that value. Okay, so it's not like in algebra where you can like cancel out the x's on both sides and get 0 is equal to y. No. Algebra people sometimes have their brains explode when they see this. This is not the equal sign from algebra. This is the assignment operator. It means set the value of x to 200. Very good. Okay? And of course, we'll do division, and we'll do modulus in just 1 second. So if x is equal to x divided by y, what value is x going to have after we do the division? A lot less responses on this one. Just wait for somebody else to answer and answer it. Yeah, okay. All right, 0 it is. Very good, very good. Previous class is all saying 0.5, which it's not. It is most definitely 0 because we are doing integer division. Well done. Give yourselves a round of applause. You guys definitely beat the 12 o'clock class on this one. And then if we were to do modulus, then what value are we going to get? 20 divides into 10 0 times the remainder of 20 divides into 10 0 times the remainder of 10. Okay. Yep, it's third grade, fourth grade, long division. We get used to just using floating point numbers for everything. And so we're used to getting like 0.5 or something like that, but you won't get 0.5. You'll get 0.5 if we make x a float. Like if x is a float, remember the rule, if you mix ints and floats, the int turns into a float, and you do floating point division. So if you do that, then sure, you'll get 0.5. Cool. And you cannot use modulus, right? You try compiling it, error, cannot do it. Okay. So, one question that I get a lot is, well, when should you use an integer versus a float, right? Because a float can hold 10, that's fine, it's a-okay. So why would you use an integer? Well, so integers and floats are used kind of for different things. The thing about an integer is that it is exactly a whole number, right? There's no decimals, right? And if you were to do something like this and say set x is equal to 7 million, by the way, you can do that. The apostrophes there are like commas. Don't use commas, though. The comma operator in C++ is a weird thing. So this is setting x equal to 7 million. And if we were to just print the value of x, we'll see that we get 7 million. Cool. But if we try setting x equal to 7 billion, notice there's a warning there, and then we're going to get a warning here. And the reason for that is because integers don't go above about 2.1 billion. That's the limit. So a 32-bit integer, your normal int, ranges from negative 2.1 billion and change to positive 2.1 billion and change. You don't have to memorize the exact number. We did when I took this class. We had to memorize every digit of it, which to me is kind of preposterous. Because if you're like, well, my code goes up to 2.1 billion and 12, just don't, just use a bigger type. Use a long or a 64-bit integer instead. It's if you need to look it up, you can look it up. Anyway, so a normal integer ranges from negative 2.1 billion to positive 2.1 billion and change. 7 billion is too big. And so what happens if you try stuffing 7 billion into something that holds up to 2 billion is that it overflows. It goes over the max and wraps around to the minimum, and then it wraps around again like 3 times and ends up, so 6.3 and change, and so you end up with negative 1.5 billion. Yeah, that sounds about right. Okay. Yeah, so anytime your compiler gives you a warning, pay attention to it. There's only 2 warnings that I will ignore confidently and safely. One of them is you made a variable and you haven't used it. I know, I'm getting to it, just chill. That's one of them. And I oftentimes will leave those on. Like if I make y here and I just haven't gotten around to using it yet, then let's see, just put that back down to 1 billion. All warnings, extra warnings on main.cc. Warning, unused variable y. That one, yeah, you can ignore. I mean, don't permanently ignore it, but like when you're doing development, if you know you're going to use it at some point, it's fine. It's fine. Shouldn't be in there long term though. And then there's a similar one if you have a function and you don't use a parameter. That's sometimes okay to ignore as well. But in general, you should never have warnings in your code. Ever. Long term. Like, this would be bad code. Like, if this was my final product, why did I bother making the variable y? You know, was there something I was intending to do that I didn't do? Why is that in there? So even in a case like that, yeah, I'd probably fix it. I'd probably delete y. Okay. You should always have 0 warnings in your code. And a lot of professional programmers are of the mindset that if my code compiles and it runs and it works, we're done. Yay! And it is a sad fact that a lot of times I'll use professional code, like not like student code, but like, you know, professional code, my professional career. Somebody will send me some code and I'll have like 1,000 errors in it. And that just gives me no confidence whatsoever that this code is correct. You know? It's like, you know, it's like, I don't know, somebody hands you a trash bag full of gunpowder and lighters, and it's just like duct taped together. You know, you're just kind of like, is this going to blow up on me? Like, have you tested this? Like, is this professional? I don't know. Like, I feel very uncomfortable here, you know? So, yeah, in my opinion, all professional code should have no warnings. And if you have something that must have something that would generate a warning in it, like colors.h, no. There is something in here where I have to have a parameter that isn't used. Right here. Yeah. So this function has to have a certain set of parameters, but they're not used. And so, like, I actually will use these things called attributes to say I'm actually not using it, and it's fine. It's fine. I understand I'm not using it, and that turns off the warning. And that's the professional way of doing it, which is like, if you have to do something that would generate a warning, in this case the warning is you have a parameter that you're not using, it has to be in there for reasons, and I'm not using them for reasons. Like, that's all correct code. In that case, you can actually turn off the warnings and be like, yeah, I understand I'm not using this parameter. It's okay, you know. And then the compiler will shut up about it, and you will have 0 warnings in your code. And that's the way it should be. So, okay. Yeah, if you ever get a warning, like, treat it like the voice of God booming from the heavens, telling you, don't do that. Make sure you know what you're doing. And if you don't understand the warning, then post onto the help center and be like, yo, I don't know what this means. You know, like, if you try putting 7 billion into an int, it will warn, and it'll say overflow and conversion from long integer to integer changes value. What does that mean? I don't know what that means. What is overflow? What is a long integer? I don't know. And then one of the people on the help center, me or one of the TAs or one of the helpful individuals that just volunteer out of the goodness of their heart, they'll tell you. They'll explain what it means. Okay. So a long integer, by the way, is a 64-bit integer, and those go up to much bigger numbers. A normal integer is a 32-bit number. And so a 32-bit number has 2, let's put this in programmer mode, 2 left shifted 31 times is 4.2 billion. That's how many values there are in an integer. In a 64-bit integer, 2 left shifted 63 times, it's in 32-bit mode, isn't it? Put it in scientific mode, whatever. 2 to the 63rd power. It's a big number. Thousands, millions, billions, trillions, quadrillions, pentillions, I don't even know. It's a big number. You can get a lot more values if you use a long integer, so the 64-bit number, rather than a 32-bit number. But most of the time we use ints, because, you know, most times our numbers don't go up that high. Okay. So, it is there, though, if you need it. Make a long integer if you want. Or sometimes you'll see it as a long, and then that will hold the number 7 billion just fine. Okay, so what's the difference then between a int and a float? This is actually pretty important topic. If we put 7 billion into a float, that works just fine. If we run it, we get scientific notation. Do you guys remember scientific notation from like middle school science classes or something like that? Have you ever seen something like 7 times 10 to the 9th power, something like that? You guys know what I'm talking about? Like 3.1 times 10 to the negative 4th. That kind of stuff. Vague flashbacks. Yeah, so that's what this thing here means. Okay. So whenever you see something that's like 7e plus, you're like, what the hell is that? Like, that looks like aliens came down from outer space and were trying to talk to me. This is scientific notation. So this means 7 times 10 to the 9th power. E is like exponent. Plus is obviously plus positive 9. So this is 7 times 10 to the 9th power, or 7 billion for short. If you do the other way, 0.0001, something like that. There, let's add another significant digit or something. I don't know. Not small enough. There you go. So then we get 1.01 times 10 to the negative 6th power. So if you move the decimal right 6 times, 1, 2, 3, 4, 5, 6. There you go. 1.01 times 10 to the negative 6th power. So floats can hold very, very large numbers and very, very small numbers and positive numbers and negative numbers. We can make this negative, and it is negative 1.01 times 10 to the negative 6th power. Okay. So why would you use an int? This is actually one of the most common questions that I get from students. If floats are just better, you know, they can hold much bigger numbers, they can hold decimals, they can hold small numbers, positive, negative, what the hell is the point of an integer? And here's the answer. Floats can have error. That's the reason. Every time you add or subtract or multiply a float, the answer can be wrong in the last digit by plus or minus 1, usually. So I think somewhere in the header file somewhere, it'll tell you exactly what the epsilon boundary is or whatever it's called. But basically, if you want to think of it, floats are accurate out to about 6 or 7 significant digits. And if you add 2 of them together, you can get an off by 1 error in the very last digit. And normally that doesn't really matter too much. You know, if you're doing like video games, lighting calculations, you've got sunlight coming in, it's reflecting off a surface. If the final brightness of the light that you see is 201 instead of 202, human eye is not going to be able to tell, right? In fact, you can actually do some pretty imprecise lighting calculations to make it go faster, and the human eye usually can't see because all the errors kind of average out over time. Worst case scenario, you see a little bit of a sparkling effect from the noise, and even that can just be written off as like dirt on the surface or whatever. So that said, we don't use floats that often because of the error. Okay, if you take 100 floats, and I know this because I was writing a program that had a big list of floats and was like doing stats on them, and so what it did was it went through and it added all of the floats together, and then it went through them backwards and subtracted them back out. And my code was programmed to stop once it hit 0, and it never stopped. Or sometimes it stopped. Sometimes it ran forever. I was just like, what the hell is going on here? Like, my algebra brain is like, if you add up 100 numbers, and then you subtract out those 100 numbers, you should get 0. Not with floats. No guarantee you'll hit 0. All that error accumulates. You know, you do all that arithmetic over and over again, error will accumulate in the last digit, and maybe if you do enough of them, it comes out the next significant and the next significant, and then when you subtract them out, it might round the same way, it might not, and it didn't hit 0, and so my code ran forever. And so I had to program it to stop once it got close to 0. So when it was within an epsilon, an error, when it was near to 0, then it would stop. It's annoying. So that's my point. It's annoying. A better way of doing it would just be to count how many I added, 1,000, and then once I've subtracted out 1,000, then stop. And I would count those with integers. Integers are precise. Ints are precise. No error in their calculations. So with ints, you know if you're going to do 1,000 things, you're going to do 1,000 things. With floats, ish, 1,000-ish. I don't know, something like that. Okay, does that make sense to y'all? The difference between floats and ints. So floats can have error, but can be big and small, and have decimals. I know we're in class, so I'm going to ask, what kind of PC do you use or your specs? Haha. Let me pause the recording for a second before I tell you. All right, start recording again. Yeah, RGB effects are kind of ridiculous. For years, I just adamantly resisted buying anything RGB for my computer, and then it just got harder and harder to find enthusiast level components that didn't have RGB on it. So I finally just was like, all right, if we're gonna go RGB, we're gonna go RGB. I'm gonna get it for my, my monitors apparently have RGB on the back and they can display the logos. Like it's just a ridiculous situation, and I find it just very, I don't know what the right word is for it. But the nice thing is I can actually look at my computer, and based on the LED effects on the inside, I can see how hot it is. So I don't have to have like a temperature gauge running. I can just kind of look down like, oh, it's pretty cool right now. I used to have a water-cooled CPU, but the all-in-one pump made this little rattling noise, like there's a little baby on the inside, like rattling a rattler, and it irked me. So I ended up giving my my water cooling system to a student, and got a Noctua. It's this giant heatsink, but it's silent. Like unless I'm like really doing some CPU intensive stuff, like those fans don't turn on. Like the damn heatsink is so big, like it actually just passively cools my CPU under normal load, even when doing gaming. Like that thing does not turn on. And so I actually have like a silent computer, which I like. I like silent. How's my wire management? It's a, what kind of CPU? It's a Core i7, Core i9 7900X. I'm probably going to upgrade it at some point, but CPUs really don't matter as much as they used to. Like back in the day, CPUs were doubling in speed every 2 years, and so you had to like upgrade your MOBO and your CPU every couple years. Nowadays, it's like I had a second gen i7, like a 2600K. I had that for like almost a decade, and when I upgraded to this Core i9, it made no difference. Like there's some video games that are CPU bound, but like I ran Witcher. No CPU. No, there's no speed difference at all. The main reason why I upgraded it was for better peripheral support and things like that, like having more PCIe channels and faster RAM, things like that. Yeah, Moore's Law. Yeah, Moore's Law used to be a thing. Nowadays, it's frankly not worth it. I'm probably going to upgrade whenever the next version of DDR RAM comes out, and maybe get a SSD that uses the new standard for that as well. You gonna sell that GPU? No, not anytime soon. i9 9900, yeah. GPU with a 970, yeah. I should probably upgrade that. Wire management, it's okay. The case that I have has some wire management built in, so it kind of runs behind things. So it doesn't look too bad overall. Okay. So, floats, ints, cool. All right, so yeah, the assignment operator allows you to change. You don't have to do algebra. You can just set it to 5 or 5.12. You guys all understand the assignment operator? It sets the value of x to 5.12. That's how I describe that in English. Okay. So we run it 5.12. Make sense? And I'm more than happy to nerd out about computers all day as well. So always feel free to ask computer questions or whatever. Okay, 2070 Super, yeah, that's a decent one. That's a decent one. Okay. Okay, so let's talk about shadowing a little bit and scopes. So there's this really fundamental concept in C++ of a scope. A scope is like the area in which a variable lives. So for example, this variable here named x, it lives until the end of the scope. So for regular normal variables, they live until they hit a closed curly brace. Okay? And this matters for a couple of reasons. First of all, there's a rule in C++ that you can't have two things with the same name in the same scope. So if I tried making another variable named x, won't work. You see that? So redefinition of x. Can't do it. Even if I tried making it a float. Nope, can't do it. Redefinition. There is, you can define something once in a scope. Okay. Now, what if you had a different scope? What if I had a variable out here named x that's set to be 420? This compiles just fine. So, question for you all is it going to print 420? Or is it going to print 5.12 here? Place your bets now. I'll run in a second. Which one do you think it's going to print? 420 or 512? 5.12. All right, we got a consensus, and it is in fact 5.12. And the reason for that is because if you have two variables that shadow each other, that's this topic right here, shadowing. This variable shadows the global variable. And by the way, you can put variables up here in what's called global space. This is a global variable. In general, it's considered bad practice to use global variables. So I'm only doing here to just show you the shadowing. Right. In general, it's a good idea to avoid using them if you can. There's always exceptions to rules, including that one. So if we were to print x here, then it's going to print 420. Right? So this variable here is the global. This fellow up here. And then once we declare a new variable, now it's going to refer to the one in the current scope. Okay. And you can also declare scopes whenever you want. So this is not something the Jedi will teach you. But you can in fact just make a scope whenever you want. Have you heard the story of Darth's scope, the Insidious? You can just make a scope. That's fine. Nobody's going to stop you. And then if you have an int x here named negative 1, 2, 3, 4, 5, we've got 1x here, we got 1x here, we got 1x here. By the way, don't write code like this or you will cause my brain to leak out of my ears and I will be a sad panda. Okay? Don't actually write code like this. I'm just kind of doing it to make a point about how variables work. So this variable here goes away here. This variable here goes away here. Okay? And when we try printing out the value of x, it's going to get this one because it's the nearest one. Whatever is in the closest scope is the one that we see. Okay? And there's kind of no, when we're down here, there's kind of no easy way of getting at that fellow there. Yeah? You guys understand? And you can make scopes as much as you want. If I really, honestly, don't write code this way. Like, please, like, don't do this. This is, like I said, this is not something the Jedi would teach you. This is really, really, really bad. But I'm just kind of making a point. So what do you think? What do you think this is going to output? I'm not declaring a new variable now. So which variable is this referring to? Is that referring to the negative 0.001? Is it referring to negative 1, 2, 3, 4, 5? Is it referring to 420? Which x is that referring to? What do you guys think? Which one of the three? First one, second one, third one? How many PCs have I built before? Wow, that's a good question. A lot. It kind of gets into a ship of Theseus problem, question. Because technically, this computer that I have here is the same computer that I've been using since 95. Every piece of it has been replaced. I don't think there's any original parts left in that. But it's, still the same computer. The operating system has never been reformatted, which is really scary. It's actually, this is Windows 95, upgraded into Windows 98, upgraded into Windows 2000, upgraded into Windows XP, upgraded into Windows 7, upgraded into Windows 8, upgraded into Windows 10. This machine has never been fully reformatted. I have programs installed on here that I can't find again because they don't exist anywhere else. And so I will adamantly refuse to reformat this computer because there are programs that I need that I can't get again because the people who made them are dead. Or, for all intents and purposes are dead because they don't exist on the internet anymore. So, yeah. Microsoft went to me and they're like, you should reformat your computer. I'm like, nope. Sorry. So, the answer to this is it's going to be this one. Because whichever one is nearest is the one we're modifying. So X is going to be modifying this one, and it's going to print 5.12. Because this code here is modifying this variable here. So again, don't write code like this. You will hurt my brain. We call this job security code. Because only you and your dog can understand it. The most absurd, obscene thing ever. Yeah. So if you write code like this, they can't fire you. It's great. It's awesome. Nobody can understand it. How do we get warnings to appear while coding? Yeah, for you guys, it'll only appear when you compile it. I have a little something installed that will. It's absurd. Okay, yeah, I have something installed that will compile my code while I'm running, but I don't have it running for you guys because it eats up the CPU of my server, and the server performance goes to crap. So, yeah. If you can figure out how to enable it, more power to you. As it is, I don't, because it's constantly compiling your code in the background. When you have 50 people all compiling at the same time, every couple seconds, the server's performance tanks. What's the biggest project I've done? Why should we redefine a variable instead of just changing it manually? You should not redefine a variable. Don't do this. This is bad. Global variables, bad. Shadowing variables, also bad. Don't do this. Don't write code this way. Please, for the love of all that's sacred and holy, don't write code like this. Unless you want to not be, fired at your work because nobody else understands it. The reason why this is part of C++ is because let's say you didn't know that this global variable existed, right? So let's say somewhere somebody made that variable named X. You would need to know the names of every global variable in your project. Your project might have millions of lines of code. You'd have to know the name of every global variable whenever you named a variable. And that's like cognitively too much to demand of people. So it'll just shadow it. It'll just be like, okay, we got a new variable here named X, and it just ignores the global one. That's why it exists. So that you don't, when you're writing this, you don't have to be aware of the entire scope of the project. You only have to pay attention to the variables in your scope. That's why it exists. There is, don't do this for realsies, okay? All right, biggest project I've done. I have worked on large projects. somewhere on the millions of lines of code thing. Order of magnitude 1 million. It might have been between 1 and 5 million. I don't remember exactly. The largest I've written personally is about 500,000 lines of code, and that was too many. So I ended up spending a couple weeks ripping code out of it, and I took it from about 500,000 down to about 300,000. So I got rid of about 200,000 lines of code, and that was honestly one of the most productive weekends, was writing negative lines of code. It cleaned up everything, simplified, compacted it down, made it a lot more readable. Basically refactoring my entire code base to be better and cleaner and easier to read. Yeah, so somewhere on the order of like 500,000 for stuff that I've written. Okay, so let's talk about, we've talked about the assignment operator. It just sets a value of something. Talked about scopes and shadowing. Please no. Okay, there you go. There's the lesson. Don't do it. Talked about ints ranging from -2 billion to positive 2 billion, floats of error in them. Yes, we use ints because they don't have error. All right? That's why ints are our go-to default type. For most purposes, we use ints. You might think, oh, for like dollars and cents, right? We'll just use floats. Trust me when I say banks don't like error when it comes to money, right? You don't want money to just vanish, right? So rather than holding, like, let's say that your price of something, let's say that the price of like a sandwich or something is like $7.21, right? Rather than doing that, it's a lot more common to do something like this. And just hold the price in an integer, which doesn't have any error in it, and just hold cents, right? 721 pennies is the price of the sandwich. Does that make sense to you guys? Because you don't want to like let your money, even if it's a penny here and there, like, you know, if you're doing a lot of transactions, it's people get upset at you when money vanishes, or if you make money out of thin air. Do you guys understand this? It's like the price would be like 721 pennies, right? Like, a lot of new programmers' instinct would be to use a float, but in real life, we really don't like error in our code. Okay. The max is on Linux. I know the fingerprint. Kind of done that. So every stage server has its own public key. This is just asking you to approve it for the first connection. Yeah, so the first time you connect to the server, it'll ask you if you want to save the key of the server. So if the server ever changes, like if somebody were to take down my server and put up a new one, it would warn you, be like, warning, warning, you know, somebody's impersonating your server. Okay. Makes sense for accuracy's sake. Okay. All right. So let's talk about the big thing for today. Big, very important thing. And the big, very important thing is if statements, conditionals, branches. These are different terms to refer to the same thing. Okay. And what it is, it's how you make your program either do one thing or another. Okay. So if you're, I don't know, implementing a password system, and you're going to ask somebody what's their name, what's their password, you either want to say access granted or access denied. Okay? It's a branch. It can go one way or it can go the other way. It's like a fork in a road. And so in C++, we do this using if, and not with two eyes, with one eye. If. Notice how it turns yellow? Yellow means that it's a reserved keyword. In C++, it's a special word. Okay? You can't make a variable named if, by the way. You can try doing that. Int if is equal to 5. It will get mad at you. This is a reserved word. You can't do it. Okay. So how do we do that? How does it work? Well, let's see. Int x is equal to 10. If x is less than 10, see out hi, else see out bye. Here's the overall look at the thing. I'll go through the syntax in a second. But basically what it means in English is if the value of x is less than 10, then print hi, otherwise print bye. That's what this whole thing here is doing in English. Right? So it's checking to see if the value of x is less than 10. If it is, prints hi. If not, prints bye. So which one do you guys think is going to print out? Is this going to print out hi, or is it going to print out bye? Logic. Yeah. I keep getting drip coffees with like a shot of espresso added. It just doesn't work that well. Ciao. Adios. Yes, it will print bye. Okay, so let's go through the, and I can run it if you don't believe me. Bye. Yep. So let's go through the syntax on this, and I'm just going to actually pull this out. The else is optional. You don't actually have to have an else in there. So in this case, it's saying if x is less than 10, print hi. Otherwise, do absolutely nothing. Okay, you don't actually have to have an else in there. Okay. So if I were to run that, it will print absolutely nothing. Okay, so let's go through the syntax. So whenever you do a conditional, and this is the brains of a program, this is where all the intelligence in a program exists. If you didn't have any if statements, your program would run the same way every time. It would start at the top, go to the bottom, no deviations in form, it'll just run. And it's a very boring thing for your program to always do the same thing. So, syntax, if, followed by parentheses, smooth parentheses, regular parentheses, shift 9, shift 0. Okay. Inside of the parentheses is a Boolean expression. A Boolean expression means anything that evaluates to true or false. So in this case, x less than 10, it'll compare the value of x with 10, and it'll either be true if it's less than 10, or it'll be false if it's greater than or equal to 10. Okay. So whatever is within the smooth parentheses here will be true. If it's true, then it will execute everything between the curly boys. That's how an if statement works. It evaluates the parentheses. If that thing evaluates to be true, then it executes all of the code between the curly braces. Okay? That's what an if statement is. And if what is within the parentheses is false, it does not. It will skip over it and see out twas brillig. Anyone know what that's from? NYSC song. Notice how it skipped right over this, right? Because x is not less than 10. So it skipped over everything in the curly braces. We could have, a million lines of code there. It doesn't matter. It will still just print twas brillig. Anyone? No? Jabberwocky? Twas brillig in the slithy toves, did Gyron gimble in the wave. All mimsy were the Borgroves and the moraths at Grabe. Lewis Carroll's one of the famous nonsense poems. Beware the Jabberwock, my son, the jaws that bite, the claws that catch. Beware the juju bird, shun the frumious bandersnatch. So he took his vorpal sword in hand, long time the maxim foe he sought, and rested he by the tumtum tree and stood a while in thought. And as in uffish thought he stood, the Jabberwock, eyes aflame, came whiffling through the tulgey wood and burbled as it came. 1, 2, 1, 2, and through. The vorpal blade went snicker-snack. He left it dead, and with its head he went clumping back. Oh, hast thou slain the Jabberwock? Come to my arms, you beamish boy. Oh, frabjeste cluculae, they chortled in their joy. 'Twas brillig in the slithy toves, did Gyron gimble in the wave. All mimsy were the Borgroves, and the moraths out Grabe. There you go. Absolute nonsense. Still, pretty good poem for being complete nonsense. So, if we add in here an else, what this means is if that part is false, then it runs the things between the curly braces. Okay? So if what is within the parentheses here is true, it'll execute this code. If what's within the parentheses is false, it will execute this code. That makes sense? So it'll either go one way or it'll go the other way. The else is optional. You don't have to have one. But that's how you do it. Okay. So let's make it a little more interesting. Let's read a value from the keyboard. Okay. And if the value is less than 10, we will print x is less than 10. And otherwise, we will write x is greater than or equal to 10. And it'll print 'twas really good. Okay. So what number should I type in? Give me a number. 12 it is. X is greater than or equal to 10. Cool. 7. All right. 7. X is less than 10. Okay. 2.19. Less than 10. Although, trying to read a float into an integer is problematic. So, you should probably talk about recovering from errors at some point. But okay, so yeah, and we can actually stack these things together if you want to have more than just 2 options. If you want to have 3 options, like what if it's equal, we can stack them together with an else if. So we've got 3 options when doing a branch. There's if, else if, and else. And so we can say else if x is equal to 10, else so we can do 3 options. So in this case, if x is less than 10, it's going to print x is less than 10. Otherwise, if x is equal to 10, by the way, equal to is 2 equal signs. 2 equals. Not 1, 2. This is the single most common mistake people make in C++. Probably is that they will write 1 equals there. 1 equals is assignment. It will set the value of x to be 10. It will not do what you think. If you want to compare 2 values, it's 2 equals. 1 equals is assignment, 2 equals is comparison. Do not confuse the two. Do not confuse the two. It will warn you if you do that. If you do that, it'll warn you. Warning, you're using the result of an assignment and a condition without parentheses. Again, treat warnings as the voice of God booming at you from above. Don't do that. You're doing something wrong. And if you don't understand what it's telling you, like, okay, maybe I'll just put parentheses around it and then it'll go away. No. If you don't understand what it means, ask on the help center. Okay? And people will be like, oh yeah, you're using 1 equals instead of 2. 1 equals is assignment. 1 equals will set the value. 1 equals sets the value of x to be 0. Okay? 2 equals compares the value with 10. So this will return true if x is 10, and it will return false if x is not 10. Okay? Can you keep nesting else if like that? Yep, you can do that forever and ever if you want. As many times you want. I have seen if-else if things that run on for 40 pages. Yeah, no, it's true. It's like if you have a long list of options, then you just have to handle them at some point. You know, if you're making a video game that's got 40 weapons, then if my current weapon is the rocket launcher, call rocket launcher fire. If my current weapon is grenade launcher, call grenade weapon fire. There's ways around that to make it more compact, but at some point you're going to have all of your options handled. You know, if you look at oh crap! I just deleted Discord. Let me go back into Discord. I'm wondering where the hell I went. Sorry about that. I just closed Discord by accident. Okay, let's put that back on. Can you guys hear me? I meant to click on this icon here, and I went right off into the next screen and clicked on the X for Discord. Okay, so if you look at like the menu on most programs, there's usually a lot of menu options, right? So there's a file and an edit menu and all this kind of stuff. And there's just a lot of options for you to click on. And so at some point, you're going to have to handle them. And there's different ways you can organize that. Like sometimes they'll be set up using these things called callbacks and things like that. But yeah, sometimes people just be like, if they chose reset terminal, reset the terminal. If they chose clear scrollback, clear the scrollback. You know, and so yeah, it's not uncommon to see if else if else if else if else if else if that run on forever. I'm not necessarily advocating for it. I'm just saying like you'll see it. Okay, so early leave. Yeah, class is over. Kidding. We still got 20 minutes left. Okay. So the format for this is if, followed by else if, as many else ifs as you want, followed by else. Okay. And the else will activate if none of the above, right? So if this is false, and this is false, and this is false, then it'll do that. So out of all of these options here, it will do exactly one. So if x is less than 10, it'll print x is less than 10. Then if it's not, then it moves on to here, right? And then if that's not true, then it moves on to here. And if that's not true, then it moves on to here and prints it. Okay. X is greater than 10 and is not 20. Switch statements. Yeah, I don't like switch statements. So if we type in 9, x is less than 10. If we type in 11, x is greater than 10 is not 20. If we type in 20, x is equal to 20. If we type in 10, x is equal to 10. Okay. So our thing here is handling all of them. Yeah, there is something called a switch statement, and I highly recommend you guys not use them. Zybooks will talk about it, so it's not like you're going to be neglected in your knowledge of C++, but there are really good reasons to use switch statements, and none of those reasons apply right now to you. I would use if, else, if blocks for everything. And switch statements can't do this either. They can't do a comparison with like less than or anything like that. Switch statements are only used for a bunch of equals, equals, equals. I have seen more bugs caused by people using switch statements than almost anything else. It's the first thing I see when I see a student use a switch statement is I'm like, they probably did the switch wrong. So just, I think you can decrease line count by formatting it differently. Yeah, you know, if you want, there is a rule that you can omit the curly braces if you have a single line of code. So I could do that. My fellow computer science professors are screaming in horror right now. This is fine. I mean, it's perfectly valid C++. It's the same as before. Is it a good idea? I don't know. Maybe. I don't know. It's one of those. It gets into the issue of style, and I really hate coming down on matters of style. You will see people advocate, though, to always have curly braces. That said, I like not wasting vertical space on a screen, so I will write code this way sometimes. It depends. If you really want to go compact, you can actually do that and turn what was before 12 lines of code into 4. Depends. I don't know. What do you think is more readable? I don't know. Sometimes I'll put like a vertical space there to like break up, I don't know, break up different sections of the code. Just to, because remember, source code is for people. All right, source code is for people to read and understand. And so the single kind of overriding concern when it comes to style is like, what will make it the easiest for a person to look at the code and understand what you're doing and see what's going on with your code. And people have a lot of different opinions, and they will fight very vociferously and energetically over what is the best. For now, I would probably always use curly braces. That's just a good starting point for now. Okay. So my advice to new programmers is to use curly braces. I'm not super passionate about that. If you want to get rid of them, you know, you do you. Also, some people will do it like this instead. This is fairly common. That. So that, I think that's actually how I was taught how to do it when I was in your shoes 20-something years ago. We had to do what's called a detached or a hanging curly brace like that. Yeah, some people like it better. It's again, I don't really have strong opinions on the matter. I try to preserve my vertical spacing because a lot of people space things out so much vertically. When you're doing small programs like this, it's not a big deal, right? But when you're in a big program, if you have to like page up and page down to like see what's going on, mentally, like you kind of lose track of where you are. Like every time you page up, like it scrolls things off the top of the screen. You sort of, it's hard to like keep things off the screen in your mind and things like that. So I do try to keep things close to each other vertically if they should be next to each other. Again, it's not something I'm super passionate about. So if you like this look better, go for it. Some people do this, where they like indent the braces that. There's a lot of options. When you run compile on the code, by the way, so if you say compile main.cc. One of the things it does is it reformats your code the way I like it. So, see that? So, this, I have it set up to reformat the code I like, and that's to teach you my style. But just be aware, I don't really care. And if you want to use your own style, more power to you. All right, so we got different options. So we got different options for doing comparisons. There's less than, there's double equals, and then there's a few more. There's less than or equal to, greater than or equal to, and that one, which is not equal to. So not equal is the one that students oftentimes have questions about because why is it screaming at me? Why is there an exclamation mark? It's not an exclamation, well, it is an exclamation mark, but in computer science, the exclamation mark means not. Okay? I don't know why, but exclamation mark means not. That's just how I mentally read it. Not equals. I just read it as not equals. The other things make sense, right? It's like if we used less than or equal to here. You guys with me on this? Like this isn't gonna blow anyone's mind, right? Like pretty straightforward. This is the only one that students are like, wait, what does that mean? Not equal to. So when we enter a value, if the value is less than 10, it's going to print x is less than 10. Yeah, that's not especially equal. Let's make it 20. Okay, so if that's not the case, then it'll come down here and see if it's less than or equal to 20. Then it's going to check to see if x is not equal to 20. And then that's it. It can't actually this else statement will actually never appear. This can't be. Okay. You guys understand why? Would you say it's good practice to have a consistent style? Yeah, that's really the only rule that I have, which is that when you have a style, just stick to it. Because if you mix and match, like, it gets really hard to follow. Like some people, they'll always start an integer with like an I, so they'll call it like integer underscore x, and then if you like do that some of the time and not do it some of the time, it's just like eyes are bleeding, stuff like that. Okay. So why can this not be reached? Why is that never going to be printed to the screen? What do you think? Okay. because we've already reached a condition for one. All possible, yeah. This is pretty exhaustive, right? This is catching everything. So either it's less than 10, or it's less than or equal to 20, or it's not equal to 20. That's all possible integers, right? These are pretty exhaustive. Okay, so if we run this a few times, 20, it's less than or equal to 20, 10, it's less than or equal to 20, 1 is less than 10, 21, 21. So we can never get to that else. Okay, so let's talk about strings a little bit. So a string is a new variable type. A string holds one, technically 0 or more characters. A character is like a letter. It doesn't have to be a letter. Like the exclamation mark is a character. Okay. So this is a new data type, and we can read from the keyboard into it. When we read from the keyboard into it, it reads one word. It doesn't read two words, it reads one word into the keyboard. And then we can use our if statements. Like we could do something like this. We could say, cout, please enter your name. And I guess we can call this name now. Huh? And then we can do the same thing for password, I guess. For s password dot x dot. You guys ever wondered why Vim is awesome? That's why. I could have retyped all that, or I could just use the power of Vim. So it's going to read the name. It's then going to read the password. And then we can do an if statement. If name equals Bill, and that's a new thing. Yeah, we can use and or not. These are logical connectors and things like that. So if the name is Bill and the password is, somebody give me a password. Cheese wheel. There we go. That works. Password 123. The previous class, they gave me Naruto 313 or something like that. So if I type in my name is Bill and the password is cheese wheel, by the way, it's case sensitive, then it'll say access granted, welcome to the mainframe. Otherwise, we will see out error. Access denied. The NSA has been informed. Okay. And then if we want to quit out early, we can return it. That bails out. This returns from name, which is... Okay. And then we can like see out, I don't know, stuff. Okay, so that and there means if my name is Bill and the password I typed in was cheese wheel. So this will only print access granted if both my name is Bill and the password is cheese wheel. So if I type in Bill, cheese wheel, access granted, welcome to the mainframe, and then the program keeps running down below. If I type in anything else, error, access denied. If I type in my name is Bill and my password is Naruto 313, it doesn't work. If I type in Lee and cheese wheel, doesn't work. You guys understand? So an and requires both sides to be true in order for the whole thing to be true. Now if I used an or here, then if either of them is true, which is a very insecure system, type in Bill, my password is... Or if I type in Lee with the password of cheese wheel, also bad, very bad. Okay. So and is the right thing here. Why is Bill in double quotes? Double quotes indicate a string. Okay, so this is comparing the word that was typed in with the word Bill. If I didn't have double quotes here, it would assume that Bill is a variable, and there is no variable named Bill. I could compare two variables that way. Okay. So if I wanted to add another account, I could be like, or name is equal to B, and password is equal to password 123. And I'm going to wrap these in parentheses because order of operations, technically it'll work without the passwords, but I always like putting passwords in to make sure the order of operations goes the way we think it works. So we will allow two people on the server now, either me with a password of cheesewheel or Lee with a password of password123. Okay, so the or says either one or the other, or both, although in this case it can't be both. Bill and capital, yeah, with a lowercase and a capital, it will not. So if I type in Bill as my name and cheesewheel, doesn't work. It's case sensitive. So if I type in Lee with a password of password123, it works. If I type in Lee, password of cheesewheel, does not work. You guys understand? So this is really important. So we've learned actually a lot of really important stuff today. If statements are the brains of your program. This is where all of the intelligence of your program will take place. Everything intelligent in your program takes place in an if statement. Okay. What kinds of things can you put in an if statement? You can do comparisons, less than, greater than, double equals, greater than equals, less than equals to, and not equals. And then you can join together comparisons using and, or, and not. Right? What games do I play? Right now, I'm playing Orcs Must Die 3. It's pretty fun. The power of logic. Yeah. So by using these comparisons and these logical operators, you can basically do anything you want. You just kind of have to think about it a little bit and be like, all right, how does this work? And then you can have your program do one thing, or you can have it do another thing. Yeah, and then strings are used whenever you do that. Whenever you read in a string, it reads in a word. It doesn't read in two words. It reads one word. Okay. Play Valorant. I've never been. Well, I should say that. Maybe I'll play it someday. Who knows? Can you use logical operators with int as well? Sure. Yeah. So if we wanted to do that, let's say int x equals 10. If x is less than 10 or x is greater than 10, yeah, it's fine. You'll also see a lot of people write. Oops. You'll see people write code like this. That means or. Double vertical slash means or. And double ampersand means and. That is and. That is or. Oops. That is or. Okay. So that is probably more common than writing the words for sure. So make sure that you're familiar with the double vertical slash and the double ampersand. Okay. So, yeah, but you can conjoin any combination you want. And if there's any doubt as to the order of operations of something, use parentheses to kind of say, all right, do these two first, then and it with these two, something like that. When to use John to crack passwords on the server? Probably pretty soon. Do you mean one word as if you include spaces, words after and stored? Yeah. So let me show you what I mean. So I'm going to read in my name, and it's going to output my name, right? But if I type in Bill Kearney, it only reads in Bill. Do you see that? So if you type in Bill Kearney, it reads in Bill. Then when it reads the password, it reads in Kearney. You notice how it didn't actually give me a chance to type anything for the password? That's because Kearney was still in the input buffer. So whenever you use double right arrow with cin, it gets a word, and that's determined by spaces. White space, any white space. So if I were to type in Bill Kearney, then it makes it a little more obvious what's happening. Kearney is going to be the password. But words are broken up by white space. So if we type in Bill tab Kearney, Bill gets read in as the name, Kearney gets read in as the password. It throws away all the white space in between. Okay. Yeah. I have a friend at Respawn Entertainment. I probably should. How do I get out of read-only mode? You quit is the easiest way. If you have Vim open multiple times, foreground the one that you backgrounded with Control Z. Control Z is not undo, it is background. If I hit Control Z, it backgrounds it. If I launch Vim again, and you go open in read-only mode, you're in read-only mode. I think technically you can like use W exclamation mark to save it, even if you're in a read-only mode, but the correct thing to do is to quit and type FG foreground, and that will foreground the thing that you minimized using Control Z. So strings only use one word. No. You can have a string that has more than one word in it. That's a string that has more than one word in it. But when you do input, the input only reads one word. Because otherwise it doesn't know when to stop. You know what I mean? Like, how many words do you want me to read? 3? 5? I don't know. You know. And so it's very specifically just for the cin double right arrow. That means read a word. There's other options to read a character, and there's an options to read a sentence. So there's 3 different ways you can do input. This one is a word at a time. Okay. So that is it for today. Make sure you guys get the Zydex done by Wednesday. And then I think we have enough now for you to actually get your first programming assignment. That'll be on the next class on Wednesday. So get the Zydex done. That's the only thing you have. That's due on Wednesday. Make sure you don't wait till the last minute on it. All right. Cool. Any other questions? Sounds good. Coolio. All right. See you guys.